So I'm going to do a little rundown here of the wiring at the rear. Of course, part of this is to share with anybody else who's interested. But the other part is so that it can help me to remember exactly what I had going on at this point in time. So aside from lots of documenting on paper and in Excel spreadsheets about wire color and sensor and etc., these videos seem to help me a lot. So I finally got all the harnesses, individual harnesses run back here. And so let's see if I can step through them. There are several sensors that I've added to the rear. They're essentially all of them are either 0 to 5 volt sensors with a 5 volt in and a 0 to 5 volt out, or there are a few of them that are NTC, or essentially a variable resistance. So mostly the temperature sensors. The resistance goes up or down dependent on temperature. And then I've added a few components that will require an output signal, so either a 12 volt power signal, like the scavenge pump, which of course I've had on here since day one. This MAC valve, which I'll use for boost control. Well, let's see, I'll step through them. So this is a wideband oxygen sensor that I've been running. It's post-turbo. These other two wires here, one of them is Type K thermocouple for EGT right at the turbine housing inlet. So that's this guy here. And the wideband is right there. The other three wires are from the Egt speed sensor. So that's the speed sensor that Borg Warner uses for their EFR series and also for the Airworks series turbos. So the reason why these guys are being kept separate is that they will go into their own essentially intermediate controller before going to the Arduino as an input. So of course the wideband sensor requires a wideband controller. The EGT signal is just a 0 to 1 volt, which I use this guy here. It's kind of covered up, but it's called an EGT-K. And essentially the EGT wires plug in here. It's got a 12 volt power supply, and then out is a 0 to 5 volt linear 0 to 5 volt signal that you can convert directly to temperature. So that's a nice little Type K thermocouple controller. And then the Egt speed sensor, that puts out a 0 to 5 volt square wave with a variable frequency. And what I'll be using for that guy is this thing. So this is from Monarch Industries. It's a laboratory grade, Monarch Instruments. It's a lab grade signal converter. So you can program this guy, and you can accept a number of different frequency or pulse width modulated inputs here. Plus it provides a 5 volt out. So all three of those speed sensor wires will connect here. And then on this end, it also is powered by 12 volts. And then there's a 0 to 5 volt analog out that, depending on how I program this thing, that will determine the scaling for the Arduino. So this is something I chose to use instead of processing that signal directly with the Arduino. It simplifies things on my end, and those things are really robust units. So those guys are all unique. The rest of this are pretty standard bits. So let's see here. This wire is again the turbo oil pressure in. So it's a sensor that will essentially be reading the pressure, the oil pressure at this inlet. The sensor will be located just a little further upstream on the line. These guys are to a air temp sensor. So this is an air temp sensor that I've added here. And I'll be welding in a bung there, so I'll be essentially able to monitor what is the air temperature right at the inlet of the turbocharger. So that'll give me an idea about what kind of air I'm getting back at this filter, which I don't know yet. So far I've just been monitoring ambient temp. This extra long guy here, this is wastegate position. So again, this will tell me if wastegate is opened at all, and if it is, by how much. So it'll tell me, it'll help me to control the e-boosters and know if I can go up or down in turbine housing size or even turbine wheel if I want to play that much. These four, one is for pressure, the other one's for temperature. These are they go to a Bosch T-map sensor. That's mounted in the charge plumbing right there. So that all measures pressure and temperature after the turbocharger, but also after the e-boosters. So after everything has been pressurized or compressed, however it's going to be. How warm is the air and what's the pressure? These wires are essentially a fresh harness that I just made this morning to redo some of the wire colors. But there's a 5-volt power, 5-volt ground, just for sensor, and then all these four are those. So you got 5-volt power, gray, ground is brown, and then I've got a position sensing 1 and position sensing 2. So one increases, one decreases voltage. Again, these guys are for this Mopar style throttle body, which I'm using as a bypass valve, electronically controlled bypass valve. And I've reversed the spring in there so that it sits naturally open, and I will control it, I'll drive it closed anytime that I want the e-boosters to do their boosting. And then the other two wires, which are slightly larger gauge, these guys are the motor positive and negative, or power wires for the actual throttle body. So those 6 wires do the throttle body. Well, I should say bypass valve. And then these guys are the T-map sensor that I just added. So same deal, I've got gray and brown for 5-volt power and ground, and then the blue and white are pressure and temperature. But these guys are measuring right here. That's the sensor right there. And so that'll be measuring the temperature just out of the compressor, both temperature and pressure just out of the compressor, but before it goes to the e-boosters. There's that. And then this final combo here, these are the ground and power for the boost control solenoid. So these will all be bundled together along with these guys, but separately. And these guys will all run into through a grommet that's right here. I'll replace this guy with something that allows a bit more wires to go through. And they'll all ultimately end up in this cubby here, which I'm going to design a new 3D printed housing. It'll hold the Arduino. It'll hold still these two, the Innovate wideband controller, that's an LC2, and the EGTK. It'll also hold, again, the Arduino Mega. It'll hold a H-bridge controller that the Arduino will command, and then still these Dill Blocks modules for the relays and fuses. So all that will plug in there. It'll also house this guy. So I'll have easy access in the trunk. And then these wires will stay separate so that I can keep track of them up here. But also, if I need to swap out any of these components, I won't have to undo them from the main harness. So the EGT thermocouple, if I need to replace that, I'll keep him separate so I can run the wire in and out a bit easier. Same thing with the oxygen sensor. This, of course, comes all the way from the sensor, so I will leave him separate. And then wiring for that speed sensor, since it's going directly here and not to the Arduino. So that'll help me remember what's going on here, and maybe give other folks an idea about the craziness going on. So, boy, 10 minutes, over 10 minutes of talking about that. Woo!